Yes.
Whatever 4 do we also consider this?
Yeah, it's the same. I'm just taking a different angle.
But like pi divided by 8 is 20.
Is what?
22 point something.
22.5.
5.
Oh, that is not the same.
Yeah.
Because 22.5 is half of 45, right? Oh my God. So we can't do this yet.
Not with this.
So it's not within this. I'm sorry. So do you want to change this directly now to 5 pi over 12?
Okay.
But this is here. 5 pi over 12. Sorry. What is pi over 12? 15.
15.
Okay, that can be done.
Okay.
That can be done.
Oh, yeah.
That can be done. But it doesn't mean, please do not work this separately, then put them together and square. I need you to use something very smart here. Okay? So you're not going to work this out and do the sign, then substitute the answer and expand the bracket. Oh, that's too much. So I need you to think of trig identity that you have done before now. You have to think of a trig. So if that is the case, then you mean that a plus b all squared. Oh, no. Which is not, last time I checked. Does anybody need a clue for number 5? Please talk to me. before this, we need to look at trig of angles and negative quadrants. Ready? So this is still application of compound angle and special angles. Okay. So maybe I put triple angle, then before I go to equation within quadrant. So let's include triple angle at this point. Is anybody stuck somewhere with any question? Question 5. You question 4. Question 4 is easy.
I got 0.
You got a 0? No. But you told me what this number is the last time. You said it's 75, right? So this is like 75 is what? 30 plus 45. That's what you have to do. But what is 30 in radian form? That's pi over 6. And what is 45? Pi over what? Huh? 0 over 4? Yeah. So you have to break it down.
I'm using a degree form.
No, if the question is in this form and you use the degree form, it's 0 for me. You have to communicate. Did he break it into these two? How did you guys do it? Maybe you have it different. This one? I'm talking about it. You haven't done this. Has anyone done this? Just a minute.
No, it's about this question.
Yeah.
Can I just convert to degree and just do it?
No. If the question is in radian, from the beginning to the end, should be radian. There should be no mention of degree. I mentioned degree so it is easier to process. Hello, listen. If you write in degree, it is 0. Because it's in pi, radian form. I mentioned degree so it is easier to process. It is easier for you to write 75 is 30 plus 60, right? Than you thinking 5 pi over 12 is going to be pi over 6 plus pi over 4. Okay? But don't write in that form. Okay? It's like giving a question in Chinese. And because I do not understand Chinese, how to write properly in Chinese, or it's difficult for me to write in Chinese, I interpret the question in English, I write back in English, and I submit the paper. Have I done the right thing? No. Does it make sense? You're supposed to communicate in the exact language. So what you should do is to say, this is tan pi over 6 plus pi over 4. Then you use the addition compound angle, the addition one. Is that understood? So what is tan A plus tan B? Yes, that's a fraction. Tan A, right? Plus tan B, 1 minus tan A tan B. That's it. Okay? Now this is tan 30. What is that? So now listen. I know this will be kind of complicated fraction, alright? So watch what I'm going to do here. Tan 30 is what? 1 over root 3. So you see, I'm calling it tan 30 because it's easy for me to process, but I'm actually dealing with pi over 6. Okay? But it doesn't mean I write 30 degrees on the board. No. Tan 45, 1. Right? Then also, 1 minus 1 over root 3 times 1. So you can see I'm having fraction over fraction. So the best thing is brackets divided by bracket. Numerator divided by denominator. Okay? Because if this is a non-calculator paper, you can't just type something and write the answer. You need to know how to simplify. So this would be root 3, 1 plus root 3, because now it's a fraction, right? 1 plus root 3 divided by root 3 as a single fraction. Do you agree? Hello? Agree? Okay. The other one will be root 3 minus 1 divided by root 3 also as a single fraction. Okay? Am I too fast? So what I've done here is 1 over 1. So that will be root 3 over root 3. Okay? So that will be 1 plus root 3 over 1 root 3. The same thing here, this is 1 over 1. And this one is immaterial. Times 1 is gone. So what I have is actually 1 minus 1 over root 3, which is 1 over 1 again, which is root 3 over root 3, to have the same denominator. So you can just take your time and simplify properly. Okay? So, with this, I can have 1 plus root 3 over root 3 times root 3 minus 1. Yes? So now I have binomial sort at both numerator and denominator. Then I can apply the conjugate. 1 plus root 3. The conjugate is still 1 plus root 3. No, the conjugate of the denominator, I mean. No. Root 3 minus 1, I mean. Right? Sorry. Root 3 plus 1. Root 3 plus 1. Let's follow the format. Root 3 plus 1, which is also 1 plus root 3. So let's just write it properly. So this is the same. So just a square. So take your time to expand. If you know the expansion, write it out. If you don't, take your time to expand it. So I have something like this. 1 times root 3, 1 times 1, root 3 times root 3 is 3, root 3 times 1 is root 3. And here is difference of 2 squares. Root 3 squared minus 1 squared. So here now I have 2 root 3 plus 4, and here is 3 minus 1, which is 2. So 2 root 3 plus 4 divided by 2 gives what? Root 3 plus 2. Or 2 plus root 3, depending on which comes first, depending on the format expected. If no format is specified, this is okay. So if you put this in your calculator, check if you have this. Who has done this? What did you do first? Expand. Expansion is the first thing. Expansion is the first thing. Why is that the first thing? Look, this is like giving you, everybody, that's like, remember it's the same angle, right? Okay, it's the same angle. So think of this as sine alpha, cos alpha plus sine alpha all squared. And you have expanded this before. I don't know if anyone remember. This is cos square alpha, 2 cos alpha sine alpha, plus sine square alpha. Yes? This and this combined gives what? 1. So this is 1 plus 2. It doesn't matter if sine comes first, right? So I'm going to write it as sine alpha cos alpha. Can you see that? And that gives what? 1 plus, remember this? 2 sine theta cos theta is sine 2 theta. So what I will say is from, okay, or because, which of course is just the inverse of that, therefore, okay, or since, you write this. Of course, not in terms of the pi. You can leave it in terms of alpha. So you are more or less showing the identity first, if you want to. So after this, it implies that cos pi over 12 plus sine pi over 12 all squared, can somebody tell me what it will be now? Is equal to what? 1 plus, yes, sine 2 pi over 12. Hello? Is everybody following this? Because this leads to this, okay, then the original question will give that. So nobody needs to ask you how you did it, because you already generated this first. You've explained, you've communicated your idea, you've convinced the person reading your paper. If you don't want to do this, then expand this and pretend it's alpha. Okay? Until you get to this point. All this will be pi over 12. All this will be pi over 12, and when you get here, you get to this point. Is that clear? And now, 1 plus sine what? Pi over 6. Agree? What is pi over 6? What is that in degree? What? 30 degree. So basically this is sine 30. What is sine 30? 1 over 2. So this is 1 plus half, which is 3 over 2. That's it. Oh my God. Yes? Where? No. This was here before I changed that. So of course it doesn't have to be repeated. Sorry about that. Okay. So this is now 6. This is now 7. Okay, I think that's the only difficult question. Yeah? Quote and unquote difficult. So let's take notes. 6 should be easier. In fact, 7 and 8 are the easiest, I think. By 12, which is in 3 minutes time, or maybe now, we can take a break. 5 minutes, walk around, go get a drink, but of course don't get drunk. Come back. Anyway, drink coffee, whatever you want to drink. If you have chocolate, bring it out. I have chocolate in my office. Does anyone want? I go downstairs and bring it now. I need a break. Do you want, Vena? You're looking around like, okay, I want, but nobody's saying anything. I don't want to look like the foodie here. Be proud, okay? Do you want? Okay. How about you? Chocolate? No. Chocolate?
So sweet.
Chocolate. Leo? Chocolate. Clarissa? Some chocolate? Why's everyone saying no to chocolate? Oh my God. Nakita? Well, she hesitated. They're like, okay, I don't want them to think I'm a foodie. Chocolate. Are you sure you don't want to change your mind? Chocolate. What? Karen? Of course, Karen will let me down. Chocolate. Karen, come on, don't let me down. I'll go get it. Whoever I want can see. All right, so get some break, do some work, whatever you want to do.
Nikita, they lost. They lost. I was so sad. When Carlston lost,
Against,
I was so I was so sad. I was like, no, this is good for character development. This is good character development.
Just go ahead and just go through season 3 and season 4. You won't like the ending of season 4. They just stopped in the middle.
Dude, you know the setter from our. He was such a good antagonist, cause he's like you know you need a beat of that. Cause he's on the enemy team, but he's so like lovable. But he's so lovable. And like the background music, whenever he like, it's like shit's nothing.
She was me. His Japanese voice actor is the same one as Hisoka in Hunter x Hunter, which is a title part.
They're both getting teenage girls. It's okay.
就好无聊才会
我也今年可能准备
好傻逼啊！
我准备我做这个题的时候一分而已。
找我啊！不要发球。
我都会做一半。
You guys have any other class?
因为我一整年没20分没做。
Oh, I haven't watched Hunter x Hunter.
59分那个。
你考多少分
29分。
你那一个考多少分？你考29。
对啊，我很多题没做。
100。有点震惊。
有点震惊了。那边表示你你的数字倒转过来好像比我高1分还是什么的。
Wait, how do you guys already have your score?
Oh.
我的数字倒过来，你比我高10分。
Huh?
我的数字倒过来。
He gave it back to you guys?
你不91吗？
93
好不好排啊？
91。
他令自己計喎。
啊？
我的数字倒过来高0.1分的，好像。
谁改改？
没有，你是真的数学有问题。
哎，你是91还是93？
91倒过来。
对，我倒过来高
你
你。
高我10分，我倒过来你高
My
我。
butt is sweating.
没有啊，我倒。
好高。
你倒过来还是高我10分？
真的。
哦，不对，你是哦对你。我数学真的有问题。
我就说数学真的有问题，让我屁个对。
我倒过来是92。
哇，这么夸张。
对啊，我一样啊，我倒过来高你1分。我倒过来的。
I asked her when we go to I asked her, should we go before the gala show?
好厉害哦，我竟然高了1分。
He is
One more.
倒过来。
He is
Thank you. Never mind. I am.
You see? I knew it. I knew it. People are changing their mind. You want to change your mind, girl? You see?
It depends on the chocolate.
Oh, can I go buy water? I'm so thirsty.
Coffee girl. Come on.
Mr. Daniel,
Yeah.
I go buy water.
You don't
First
want?
floor.
What?
I go buy water. First floor.
You want to buy what?
Water.
Okay, okay.
And then you
Make it snappy. So let's have maybe 5 more minutes because of the water guy.
那我也要你补习，救救我！快点讲啊！快点啊，去死吧！快点！
Much chocolate here to change your mind.
快点讲！待会给你看。直接讲，我等下你不吃它。他问他们就死。我已经被骂惨了。为什么他都不会被骂？因为他教过一个。不吃，我也。
Wait, Mr. Jones.
Yes, sir.
Here plus 2, right?
Hmm?
For this question plus 2, right?
Yeah. I should have added that. You know. I haven't, but I was still recording. I haven't gotten to yours, so I will have remember.
快点讲，干嘛？你很烦哎。Brenda, are you shocked?
No, it's just scary to see.
Mine is probably around 30.
Plus 1?
聊啥能聊这么久？
Oh.
太没有。
What? It's gonna cry? Crazy.
I got 70 even after leaving like 2, even only getting like 1 point for like
You got what?
questions.
You got 70?
I got 70 raw score crazy.
With the plus 2?
Yeah, it was plus 2.
Okay. Maybe you had a bet with your mom and she promised you some money, so you're so happy.
Oh my god.
考70
This was so well thought out. If only I put it on this page.
Yep.
你考70，一等你70。哇哦！
那我排第几啊？
还好。
Okay. Do this back. Do this back. Where you get that? Downstairs? Downstairs?
First floor.
First floor, first Oh,
The machine.
Okay, Matsulango. Hi, chocolate girls. Alright. So what does multiple mean? That's multiple? More, okay? Like times something, right? So when you talk about multiple angle, you're talking about maybe twice, 3 times the angle, 4 times the angle. Please pay attention. 5 times the angle. For your level, I think you should just be concerned with 3 theta, identity. Okay, not up to 4. But I want you to just see what 4 looks like. We can look at it in class. So here we'll be looking at sine and cos of 3 theta and 4 theta. So to begin with, for sine 3 theta, or let's just say from, okay, from sine A plus B, someone is being noisy. Sine A plus B equals sine A plus B plus cos A sine B. Okay? Just sine 3 theta. How can we write sine 3 theta? Sine theta plus 2 theta, like that. Okay? Sine theta. So how do we write this in expanded form? Quickly, please. Sine theta cos 2 theta plus cos theta sine 2 theta. Yes? So this will be sine theta. Now cos 2 theta has 3 forms. Because this is sine, you choose the form of cos 2 theta that is in terms of sine only. What is that identity for cos 2 theta in terms of sine only? In terms of sine only. 1 minus. Try not to look at the book next time. 1 minus 2 sine squared theta. Okay? That would be equation 5 or so that we wrote there that day, right? Okay, it takes time, and it's in your formula booklet, so you don't have to panic if you can't memorize yet. Then plus cos theta. This can only be written in one way. What is that? 2 sine theta cos theta. The goal is to express this in terms of sine only. So we don't have a problem with this part, but we still have a problem with this part. If you open the brackets, sine theta minus 2 sine cube theta. What is this? 2 sine theta cos squared theta. What do? I still have some problems. Change cos squared theta to what? 1 minus sine squared. So this is not just about the identity you are doing right now. You are applying everything you know so far. Okay? So this will be sine theta minus 2 sine cube theta plus 2 sine theta bracket 1 minus sine squared theta. Remember the Pythagorean identity. Alright? Sine squared plus cos squared is 1. Means cos squared is 1 minus sine squared. And sine squared is 1 minus cos squared. Remember that? Okay? So we expand the brackets. Sine theta, 2 sine cube theta, 2 sine theta minus 2 sine cube theta, isn't it? So the positive terms first. So what do we have? Yes, final? This implies that sine 3 theta equals what? Yes? Come on, guys. Why do you keep quiet until I scream? Come on. Minus 4 sine cube theta. So that is the identity for triple angle for sine. So I need you to work with someone or individually and generate for cosine similarly. Does anyone remember that we have done this using De Moivre's theorem in the past? Yeah. And we came up with this same expression. And I told you that day, I must have, that there's another way to get the same expression using trig identity to be done later. Okay. I want you to do cosine of 3 theta. There is a pattern to notice. Check, let's work. What was the last number for the last identity from last lesson, please? Was it 6 or 7? Check your note, please. The last identity for the compound angle and double angle.
We did
6.
Was it 6? You didn't number it. There was a number we used. This is what I don't like about some of you. There's a reason for those numbers. Can I see, please?
No, I didn't write, but I remember just being 5 or 6.
You should pass the number. Can I see anyone who put the numbers,
Wait,
please?
which one?
There, 10.
Or maybe we just check
we
the
did
notes.
6 last.
The last was 6?
6.
Okay, so we call this 7. The numbers are meant to organize your work. So when I'm referring to look at identity 7, it doesn't mean that's the same number it's called. It's just about the way we arrange our nodes. So whatever you got,